All right. So anyway, let's start with going to the website. And we've got the syllabus schedule. And today is March. You can't see anything. You can't see anything. All right, you got one of them. And that's the left display, right? Which is, well, I don't know. How do you make this stupid thing do anything? There we go. Look at that. All right. So back to where we were. Today is March 19th, right? So that's where we are. We're going to talk about collections framework. We've got a lab on tombs of Mars coming up. And then coming up on the 11th we've got of April, we've got our exam. Somebody has got their connection and they should mute their sound because I can hear an echo. Okay, mute whoever you are, please. Okay, all right. Let's go back to the collections framework. By the way, warning, I'm mostly better, but a coughing fit is not impossible. All right. So let's see, where were we? So we talked about stacks and queues. Do you remember the difference? No? Okay, so a stack, right, is going to be a last in, first out. Think about, a stack of books maybe, or your laundry, right? Whatever you put on last is the thing you're going to take off next. You're not going to pull off the thing off the bottom of a pile. Whereas a queue is more like you're waiting in a line at a grocery store or something like that. You're going to go in the first one who got there is the one that's going to go through. So that's FIFO. Okay, first in, first out. So those are the two distinctions. And the interface to Java in the collections framework is somewhat inconsistent for this. You've got stack and you've got queue. Stack is a class, queue is an interface. There's a deck, DEQUE, which is double-ended queue, but that can be used as a stack. It's got the push and pop methods on it. And then there's linked list, and linked list can be used as either thing. And we'll talk about what a linked list is later, although many of you probably know. Questions? All right. The priority queue we talked about, right, is you put everything in and it takes out the lowest value, right? So if you just shove things into a priority queue and take them out, they come out in sorted order. So you can build a sort routine that way. And that sort routine will be n log n because it takes log n to insert and log n to remove. And we talked about constructors. The constructor of a priority queue can take a comparator. And we talked about what a comparator here, and then I show you a comparable, I guess. So compare to is a property of a comparable, right? So this is something we saw before, and that's just to remind you of the way the comparison works. Any questions there? All right. There's an example of a priority queue being used to, print random integers in order on the screen. Okay, comparable versus comparator, right? Comparable has a compare to method and it takes one argument. Comparator has a compare method and it takes two arguments. Make sense? I mean, if you think about the English words, it kind of makes sense. Comparable is, I can compare to myself. A comparator is somebody who comes in with the job of comparing, if you want to think about it that way. Okay, and then we showed you how to reverse the priority of the queue by changing the comparator anonymous interclass that you pass in. All good? You all know this cold. I gave you a test on this and you all get 100%. Well, if the answer to that question is no, then try to formulate a question. And this was a goofy priority queue that I made by creating a comparator that sorted things in a weird way, right? It sorted things that are divisible by 4 to the top. And then I showed you an example for a coordinate, right? So we're going to sort this coordinate based on first the x value and then the y. And if the x values are equal, right, then we do the y values. So that's the concept here, is that first set the diff to this dot x minus that dot x. And only if that is 0 do I change it to use the y values. Okay? Make sense? All right. Okay, so the difference here, right, is the angle brackets. So we have a comparable here with no angle brackets, and it has an object. And then we have a comparable with an angle brackets and coord. And then and then we get the type coord right there. Oops. And if you look, this one had to come in as object and get cast. And this one did not have to be cast because it had the correct type. So that's what the angle bracket does for you with a comparator or a comparable, is it gives you the correct type and you don't have to cast. Cool? Yes. I'm sorry? Oh, okay, yeah. Yes, right. If you don't put it in the angle brackets, you have to put it as object and cast it. Okay, and then here's another one. I think this is the last thing I showed you. The last thing I showed you. So what I did here is I had a coord 3 class, and I wanted to have 2 comparators available, one for comparing in the forward order and one for comparing in the reverse order. And you can imagine that, like, I could store this comparator in, say, a list or something else and pull it out and say, you know, this time I want to forward and next time I want to reverse. And so I have these 2 things written. But what I did here is I also want the basic class to be comparable. And I wanted this to be the default sorting order. Now, I could have coded this twice, right? I could have just written the same code twice. But the general rule is when you're writing code, is you try not to write the same code twice. And why is that? It's because you're always tweaking your code, right? If you're working on any kind of software project, there's always an update, there's new functionality, there's different functionality, there's fixing of bugs. And there's a chance that if I've coded the same thing twice, that I'll update one of them and not the other. And I'll start to get inconsistent behavior, right? And even if I don't forget, it means I have to do twice as much work. I have to always update both of those places. So whenever you get a chance, when you're programming, whenever you see something that's repeated, you try to think, how can I make this one thing instead of 2 things? How can I make this one thing instead of 3 things, right? You look for ways to make things more general, because that will make your life easier going down the road. Oh, digression. I saw this article, I think it came on Slashdot. There was a guy who was using AI to generate code for something. And the AI, and he said, you know, generate this. And the AI came back and it said, looks like you're trying to generate, you know, this kind of thing for a game. He said, and it said, you should really learn how to code. I'm not going to show you how to do this. You should go and figure this out. And he could not get the thing to generate code for him after that. it was quite amusing. He filed a bug report, whatever. But I just thought it was interesting that the AI had absorbed that. You should learn how to code yourself. Okay. All right. So you wanna try to reduce the amount of code you have. Also, the smaller your code is, the easier it is to maintain. There is a language which has now sort of fallen by the wayside, but it was very popular when I was, say, in my 30s, called Perl. Perl, and it's very cryptic and weird, and you have to appreciate what life was like to understand why that was wonderful at the time. But in any event, Larry Wall, who is the creator of Perl, has all kinds of great quotes about programming and computing in general. And one of the things he lists are the 3 virtues of a programmer. Laziness, because you want to do the minimum amount of coding possible. And so your code will be small and compact and efficient. And impatience, because you can't stand to wait for your code to finish, so you want it to run as fast as possible. And hubris, which means you think you're so great you can do anything. So those are the 3 virtues of a programmer. And you know what I'm telling you to do sort of fits within those virtues, right? Try to make your code one thing instead of multiple things. Any questions? All right. Okay. We did this. We talked about the sorts. So Java, of course, has a built-in facility for sorting things for you. You don't have to write your own sorter to sort things. And those are in the collections and arrays framework, depending on whether you want to sort a list or an array. And they optionally take a comparator in case you want to sort by some weird criteria. And then we talked about sets and maps. And we talked about counting words. This is actually where we finished. So we talked about how to do word counts, and we did several different ways. And the basic concept that you're being introduced to here is the map. And the map is an associative array. It's kind of like, you know, up until now, you've got arrays, and they start at 0, and they go up to some number. And all the values in between those 2 things are filled with something. And if you want to look something up, you just take that index and you look it up. And that works very well. But you're going to have more general life experiences than that, right? So what you're going to want to do is you're going to want to be able to take some arbitrary data type as your index, not always an integer, right? You want to look up something by some arbitrary data type. And you don't want to be limited to just that. And having a string as a key in a map, having a string as something that you can use to look things up is very convenient for all kinds of applications, right? You know, you've got your table of monsters. You want to know what they can do. You pull it up by name. It's very nice. Any questions about that? All right. So the map has contains key, and it has get, and it has put, and it has an iterator. You've got an entry set, and if you iterate over the entry set, you can get the key and value pairs. You can also get a key set and a value set if you don't want an entry set. And there, in addition to the tree map. So we talked about the tree map, and the tree map is always going to give you things in sorted order, right? If you iterate through it, it's always going to give things in sorted order. It's always keeping everything in a particular order. But there's another thing that's actually tends to be more popular, is the hash map. And the hash map implements the map interface and does all the same things, except it doesn't keep things in sorted order. So if you're iterating through it, you won't expect to see things in any particular order. But on the other hand, the gets and puts are supposed to be very fast. And the way it works is, instead of using comparable and comparator to keep track of things, it uses what's called a hash code. Okay, and that allows you to quickly reduce the number of things that you're looking at. And the example I always like to use is an author's last name in the library, right? It's like the, you know, Dewey Decimal System, whatever. If I want to look for Roger Zelazny, I go to the shelf and I look for ZEL, right? And all the books are sorted alphabetically by that. And if I just know, like, even the first letter of Z, right, that's going to cut down the amount of space I have to search, right? That's what a hash code does for me. And it enables a kind of random access. Random access means I can just go from start to anywhere, right? Whereas sequential access, if I don't have a hash code, another way I can find my book in the library is I can just have a big stack of all the books, and I can just look at one at a time until I find it. You can just imagine how enjoyable that would be, right? So a hash code cuts down your searching quickly, and we'll talk about how that works in some detail. And in addition to the hash code, you need an equals method because a hash code does not uniquely identify an item. So if I'm looking up this book, if I'm looking up a book by the author's last name, right, there can be multiple authors with the same initial of their letter of their last name. And so that's not going to find me my book. It's just going to cut down on the search, right? I'm only going to search the ones that have this property. And the idea behind a hash code, one of the ideas about it is it's quick to compute, right? It's not like a big data structure. It's not a string. It's not anything complicated. It's usually it's just an int, and you can just look things up with it. So let's take a look at how this works. So in Java, java.lang.objects, every object has a method int hash code, and every object has a method boolean equals with an object argument. See, I told you that could happen. I can cough. Clear my head slightly. All right. So this is something that you don't want to do with your hash code. So I have an object which I call bad hash. And every time I call the hash code function, it's going to increment this field on my hash called n. So every time I call this, I get a different value for my hash code. This is a bad thing. Hash codes should not change. If they do change, your hash maps and hash sets will not work, right? So you need something that's very stable here. So sort of a good quiz type question is if you've got any kind of mutable hash code, that's bad. And then you need an equals method, and the equals method has to complement a good hash method. And the idea is behind an equals method is it's going to uniquely identify an object. So generally speaking, you want your hash code and your equals method to do their work based on final fields, because if they're not final, then these things are going to change, and that's going to disrupt the behavior of things that are trying to use them as keys in a map. Okay, so here's another bad hash. Can anybody spot what's wrong with this hash? So remember what a hash is supposed to do, right? A hash is supposed to cut down on the search, right? So if I know the two things have the same hash code, then they might be equal, right? That's the idea. If they have the same hash code, they might be equal. Think the author's last name of a book. But if they're different, then they are not equal. So if I get a hash code of D, I better not find Roger Zelazny's book there, right? Because that will just lead to nonsense and chaos and confusion and delay, as Thomas the Tank Engine would say. So what's wrong with this code here? Who can tell me? So let's. I'm sorry. Scott, yes. Right. So Scott is saying we should be comparing the n to the n and the m to the m. So the point is, right, this n is not part of the equals procedure at all, right? So it's like comparing something. It's like comparing the color of the book jacket, right? Maybe different editions had different colors, but it's not helping you find the book, which is based on the title and the author's last name and all kinds of other things. So that's why this is also bad. So rules to live by. A key for a set or map ought to be immutable. That means you should not be able to change it. That means it should all be final stuff. A string is great. An int is great. Those are all immutable data objects. The hash key, the class you're using for the hash key, needs an equals and a hash code. The equal objects have equal hash codes, but not vice versa. So that's the thing to think about. Always think about the author last name thing. The equal objects have to have equal hash codes, but not all objects with the same hash code have to be the same. So one of the things I always like to point out is you can always use a hash code of 1, right? If you use a hash code of 1, your map and set will function. Your code will behave correctly. It just will be highly inefficient. What that means is when you're doing that sequential access thing, when you go to the library, the books are totally unorganized. You just have to look at each one until you find the one you want. And computers are fast and they can do that, but you know, this isn't a good situation, but it will work at least. Okay, so if you just have a hash code of 1, you will get correct code. You just get highly inefficient code. Questions? Everybody understood all of that? Okay, comparable. Yes. Yeah, well, the reason why it's inefficient is if it's just a constant, it gives you nothing, no handle. It's like instead of telling you that I can use the author's last name as the key to find my book, I could say it's a book, right? That it is a book. That's true. And if you look at all books, you'll find it. But it would be better if you could look at all books with an author's last name that started with Z. That would be a much smaller pile. Make sense? All right. All right, and then we have comparable and comparator reiterated. So each of these things, so you can use a hash key, a key that's a hash, or you can use something that's comparable for a key. And a comparator is sort of key adjacent, right? You can provide it to a tree set and a tree map, and it'll define how the key is sorted. But in either case, right? In this case, what we're going to do is we're going to first cut down on our search pile, and then we're going to search sequentially. And in this case, we're going to do a binary search and keep things sorted. And that's how we're going to look things up. Does that make sense? All right. So tree set and tree map use comparable, comparator, and are sorted. Hash set and hash map use hash codes and are not sorted. Those are some takeaways. How am I doing on time? All right, good. Questions? All right, well, seeing as you have so few questions, I'm going to start right in on data structures. So one of the ones that is very useful is Java util iterator. And the concept, and we've talked about this one before, it's an interface. It has a Boolean has next, it has an object next, and it has a void remove method. And then there is an iterable method, right? And that's going to have just an iterator method. And anything that works that will be able to use an enhanced for loop. And then we'll have linked lists, which can be either single or doubly linked. And then we can have map implementations. We can have an array and we can have a hash map. And here was a little example I did for iterator and iterable. So in this case, I have a class called range, and it implements iterable. And I have a low and a high, and I'm going to initialize these from the constructor. So I'm going to have an int low and int high in the constructor, and I'm going to use this dot low to initialize equal low, and this dot high equal high to initialize. Now here's my public iterator method, and what I'm going to do with this method is I'm going to return a new iterator angle bracket parentheses. That's So this is returning an integer array, and the empty angle bracket just means, use the same thing as on the left-hand side. So that's going to be integer also. And this is the parentheses for the constructor. And then here comes the implementation of the class. The whole thing is a value, right? And the semicolon comes at the end. So I need to implement two methods inside my anonymous inner class. I need to have hasNext, and I need to have next. And I'm also going to have a field in this anonymous inner class. I'm going to put int I. I'm going to initialize it with low. And my hasNext method is going to say I less than high. And my next method is going to just return I++, right? Remembering that this is a postfix operator. So the plus plus happens after I return the value. And now when I go to run this thing, it's going to print everything in that numeric range. Did you follow all that? Dead silence. What? How can that class not be there? I mean, I can just retype it, of course, but anyway, yep, there it is. Okay. Okay. So I'm going to take this class. And now it prints 10 through 14. And I actually ran it twice. It actually iterated twice. So I did that once. I did this once with the enhanced for loop, right? And I did this another time, and this is the code that the enhanced for loop expands to. All right. Now, I instantiated this range class twice. Do you think it would still work if I did it like this? You think that would still work? Anybody have an opinion? Drew? So I used to have the constructor for range right here. I said range 10, new range 1015 right there. And I just moved it out into a variable. And then I had over here, I had R equal, range R equal, I had the same thing essentially. So I created two different range objects, and I used one for each loop, right? And now instead of having two range objects, and for using one range object for each loop, I have one range object for both loops. Will everything still work just as well? Anybody have an opinion? You're not graded on your opinion. Logan. Well, let's see what it does. Oops. Remember I told you how I might cough? All right. Okay, so it just behaved exactly the same way. All right, so, and the reason is, right, is because the only thing that's changing during the course of the running of this iterator is this field variable I. And this field variable I belongs to the anonymous inner class. So if I were to call this iterator, if I were to call iter.hasNext after this loop, it would just say false forever, right? Okay, any questions about this? Drew. The hasNext turns false because hasNext is only true so long as I is less than hi. And every time I call next, it gets increment, I gets increment. At some point, it becomes false. That's when the loop terminates. And nothing ever fixes that. Good? All right. So we have lists, and Java has lists, and the list method in Java has way too many things in it. I mean, it's got, like, if I go and I look, Java p minus public java.util.list. These are all the methods on Java util.list. Now, some of them are static, and we don't care about those, but I mean, look at this horrifying list. And actually, I really only care about the abstract ones, I guess. So those are all the ones I would have to implement if I wanted to do this. And that's not even all of them, because Java util list extends sequenced collection, right? Sequenced collection. And I can do the same query. And sequenced collection has those. And then on that sequence collection extends collection. And collection has those, right? And that has iterable. So, I mean, it's just insane how many methods you'd have to implement a list. So because of that, we're going to create our own version of it called the min list. And the min list is going to have an add method, a get method. It's going to have a set method, and the set method takes two arguments: an integer for the index that we want to set, and a value that we're going to set there. It's going to take the size of the list. It's going to return the size of the list. It's going to have a clear, which empties the list, and it's going to have a prepend, which shoves things on the front. So I think all but the last one are legitimately on java.util.list, right? It's mostly just a subset. Make sense? Right? So this is what, if we want to understand how to do a list when we've done this before, that's what we care about. Okay. And then we have my array list. And this is something we did toward the beginning of the course, as we made this my array list. But now we have iterators that we can put on them. And we have a notion of big O notation. So appending to an array list is order 1. Now you might think, well, yeah, it's, normally you just shove one thing on the end. But what about those times when you have to grow the list? And it turns out that even with growing the list, periodically by a constant factor, you still have an order 1 behavior for appending. Now, if you grow your list by a constant amount instead of a constant factor, so if I just grow it by 10 every time I need to grow, then you have like order n squared. It's so much worse. Anyway, so prepending is going to be order n. Why do you think that is? Exactly. What's your name again? Brent? Brad. So Brad is correct. The reason that it's going to be order n is because I have to shove all the values over one, which means I have to copy every value in the list. And so that's going to be order n. Insert means I'm shoving a value somewhere in the middle of the list, roughly. And that, on average, is going to be order n. But then a get, right? If I look up something in the list, that's going to be order 1, right? I just go to the index and it's there. Now, a linked list, we're going to talk about that in a minute. Append is order 1. Prepend is order 1. Insert is still order n. And get is order n. The fastest thing that you can do with a list becomes the slowest thing you can do with a linked list. And a doubly linked list is going to behave similarly. All right, so those are some more things that you need to know for your big O questions. Anything you want to ask me? All right, good. And we're going to implement our own map, because the same problem that we had with the list interface, we're going to also have with the map interface. It's just too big. So we're going to have our minimum map, and it's going to look like this. We have a get, we have an object get object. So we have a key, and it's going to get the value. And then we're going to have a put, which is going to put at a given key, it's going to store a given value. And it's going to have a size and a clear. It's going to be able to list keys and values in entry set. And one of the things that we haven't talked about is, well, essentially we talked about sets and maps, right? And so they're kind of the same thing. It's kind of like a set is a map where all the values are true, something like that. A set has only unique objects, and all the keys of a map have to be unique. Each key maps to one unique value. Questions? Who's awake? Not everybody. Not everybody. Yeah, Logan. Yes. So put is kind of like set in an array list. It's kind of like, square bracket equals in an array. We're storing a value that's associated with that key. Okay. And so when we go to implement our minimal map, one of the things we're going to want to have is this data structure, which I'm going to call entry. And that's going to have a final object key, because the key shouldn't change, and then an object value. And you're going to have a constructor, which gives you a key and a value, and sets the K and V fields. And the object get key is going to return K, the get value is going to return V, set value is going to set the value, and then we're going to have a toString, which is going to say K goes to value. Very simple. And then I'm going to we can look at how we could implement a map. So in this case, I'm going to implement my minimal map. And the way I'm going to do it is dead simple. I'm going to have a list of entry objects. And I can use linked list, or I can use array list. It doesn't really matter. And what I'm going to do is, if I want to get something out of the map, I'm just going to iterate through every single item in the map. And I'm going to look for places where the key is equal to the entry key. And if I can find that, I return the entry value. And if I don't find that after going through the whole loop, I return null. Make sense? Yes, Drew. I can't hear you. Yeah, so all I've got is I've got a big list of entries. And when I want to do a get, I'm going to go and look at all of them, and I'm going to compare the key on each of them to see if I find the key that I want. And if I find that key, I'm going to return the associated value. And if I get all the way to the end of that list and I haven't found it, then I'm going to return null. So it's dead simple, right? I mean, there's nothing really to it. And then my put method is going to be kind of the same, except when I find the key, instead of returning that value, I'm going to update the value in the entry, e.v equals v. And if I get to the end of the loop, instead of, like not doing anything, I'm going to say, well, that now needs to be in my map. So I'm going to add a new entry with that key and value. Okay. But this get and put pair will work. I mean, obviously they're as inefficient as they can be, right? But the point is they're simple. And one of the things, when you're writing code, there are classes where the professors will penalize you for writing inefficient code. And I generally don't do that because you have to focus on correctness first, right? If you get correctness, if you understand correctness, things are great. If you don't care about correctness, then there's a great way to create efficiency. You just create a program that does nothing, right? Because that's not going to do what you want either, right? So might as well use that. Very often, programmers tie themselves in knots in an effort to optimize things, and we will definitely do it as well. Optimization is something that you have to do, but correctness is always far more important. And one of the things that object-oriented programming and languages like Java allow you to do is it allows you to take components and have dumb correct things that work and allow you to swap them one at a time for smart, efficient things that work better. And you always want to be able to go back to something dumb that works when you're trying to figure out how to make your code do what you want it to do. Any questions? Yes, Drew. I'm sorry, could you speak louder? Oh, so MA, it's just off the top of the screen. That's the list entry MA. So, so that's the list I'm working with. And it supports iterable, which means I can use enhanced for loop on it. All right, clear is just going to call ma.clear because the list already has that functionality. Size is going to call ma.size because the list already has that functionality. But now I have to do a little bit of work. So if I want to do my keys, then I have to do something clever like this. So public iterable keys is going to return a new iterable, an anonymous inner class. And that's going to have the iterator method. And that is going to return another anonymous inner class, which is an iterator. So we've got an anonymous inner class inside of another anonymous inner class. Just what you were hoping to see this morning. What we're going to do is for the field method inside that iterator, the innermost thing, we're going to ask for an iterator from the list that we already have. And then what we're going to do is our hasNext is just going to be ke.hasNext. Our entry is just going to be ke.next. And then we're going to return e.k, because what this is supposed to be is an iteration over the keys. So I'm going to return the key at each step. And then there's a remove method, and I can just call the remove method on the iterator itself, on the iterator that I got from the list itself. Okay, so any question about that? So if I want to make now that you've seen that and you've totally understood it because you haven't asked me a single question, right? How would I change this to make an iterator over values? This is an iterator over keys. How would I change it to make it an iterator over values? Hint, It's not hard. Logan, which thing would I switch or change? So where do I check for the keys? You're on the right track. What? I'm sorry, what? JJ? Ah, got it. Okay. Yeah, so so you want to change this line? We don't have a has next int though, and we don't know whether the key or value is any, the key and values are both objects. So this is returning the key, and this is just returning the next. Anybody else have a clue as to how I would make this do the values instead of the keys? This makes me think you should all be asking me more questions. Which method actually returns the key? Next. How could I make it return a value instead? Yeah, but the key and the value are both objects. Vanek? I'm sorry, say it again. Well, E isn't a value, right? E is an entry. An entry contains a key and a value, and I took the key out and I returned it. What if I want to return the value? Logan? E.V, right? So I changed one letter in my line of code. I changed that K to a V, right? And now I'm returning the values. Now, what if I want to return the entries? That's the third thing I need to do. Just return the E, right? If I want to return the values, I can copy this whole same block of code, and I can just return the E. All right. Any questions about any of that? All right. I expect you to work harder to ask me questions next class.